Hi everyone, welcome back to another beautiful episode of Just Ask Sage, who's back and fully ready for the festive season. We all experience change daily, but have we ever stopped and wondered how fast this changes occurs? Sometimes it can go pretty fast, sometimes it can go pretty slow. The idea of how fast something changes is what we know as differentiation. Yes, the differentiation that's giving us headache in school is as simple as how fast something changes. Differentiation simply means the rate of change of an object with respect to something. So if we are asked to differentiate a function, we are simply asked of how fast the function changes. But enough for this plenty English. Let's go back to the mathematics. So mathematically, if y is equal to f of x, which is a function, then the derivative of y with respect to x is dy by dx or y prime or f prime of x. Any of these symbols are the symbols for differentiation. Alright, so in this series, I'll be explaining everything about differentiation step by step. But before we actually learn our shortcut rules, we need to know where differentiation actually comes from, which is the first principle. So this is our differentiation by first principle formula, which states that dy by dx is the limit as h approaches 0 of f of x plus h minus f of x all over h. So with this differentiation by first principle formula, if they ask us to differentiate any function using the first principle, we must as well be able to do that. Let's take an example. Now, let's say we are asked to differentiate the function f of x equals x squared using the first principle. Now, from the first principle formula, we can see that we require f of x plus h, and we have f of x. F of x is already given from the question as x squared. So first of all, you find f of x plus h. F of x plus h. Now, if you compare these two, the difference is that instead of x, which we have here, it is now x plus h. So the answer, instead of writing x squared, it will be x plus h squared. It simply means that anywhere you see x written down, simply add plus h beside it. Now, let us solve the numerator of this formula. We have f of x plus h minus f of x. F of x plus h here minus f of x will be giving us x plus h all square minus x squared. Now, if we expand this x plus h square, we'll be having x squared plus 2xh plus h squared minus this x squared here. Now, this x squared minus this x squared will turn to 0, leaving us with just 2xh plus h squared. This is for our numerator. Now, as we can see from the formula, after subtracting, they're divided by h. So finding f of x plus h minus f of x divided by h, this will give us, here we have 2xh plus h squared. If we divide both of them by h, we'll be left with 2xh all over h plus h squared all over h. H will cancel h here. H will cancel the square, leaving us with just one h. So we're left with 2x plus h. Good. Now, after dividing, they took the limit as h tends to 0. So here, taking the limits as h tends to 0, this means that wherever you see h, you simply replace it with 0. So when you have, since we have 2x plus h, instead of 2x plus h, it will be 2x plus 0. And that will leave us with what? 2x. That means the derivative of f of x equals x squared is simply equal to 2x using the first principle. Alright, so let's take another example. Let's find the derivative of f of x equals 2x plus 3 using the first principle. So like I said, first step is to find f of x plus h. So here, f of x plus h will be equal to, anywhere you see x, simply replace it with x plus h. So instead of writing 2x, we'll be writing 2 into x plus h, then plus 3. Now if we expand this will give us 2x, then 2 times h, plus 2h, then plus 3. Alright, next step is to subtract them. So we'll have f of x plus h minus f of x will be equal to 2x plus 2h plus 3 minus, remember if you are using a minus sign, always put your function in brackets. So minus in brackets 2x plus 3. So this will give us 2x plus 2h plus 3. When you use a minus, open the bracket, you have minus 2x minus 3. Alright, so if we are to subtract here, we'll be left with 2x, we go with minus 2x, turn into 0. 3 we go with minus 3, turn into 0. So that means we're left with just 2h. So the next step was to divide by h. So our f of x plus h minus f of x all over h is simply equal to 2h over h. H will cancel h, leaving us with what? 2. So if from here we take the limit as h approaches 0, here there is no h for us to replace with 0. So our answer just remains 2. So therefore, the derivative of 2x plus 3 equals 2. Alright, that's it for now. In our next video, we'll learn the shortcut to differentiation, which is the power rule, and we'll also learn the differentials of some trigonometric identities. Stay tuned for more differentiation series. Sage out.